what is sustainability? When we discuss sustainability on our products, when we are creating the products, when we are reviewing designs, well, we are sustainable when we discuss the choice of material, the sourcing, the production of the product. But what we give to you as customers is the energy consumption. So that is really what we want to target with this presentation. We are lowering the energy consumption with up to 20% with the new OmniCore controller. And that is really using the latest technology that is available on the market and really creating the designs that will fulfill those targets that we have. And on the next slide, so I will show you 3 different areas where we do believe from a design and integration point of view that energy efficiency really makes a difference. So among these 3, the first one really is about the design of the controller itself. And I think you all are familiar with electrical vehicle. And if you're running an electrical vehicle and you're braking, so what happens with the energy that previously was just using brakes, mechanical brakes, which so ultimately got into be heat and waste. Now you're using the motor in the vehicle to actually act as a generator and charge your battery, so you can use that energy when you are accelerating again. Now on an industrial product like the OmniCore controller and the robotics business we are in, we don't have batteries. So the way we have done it is to, when the robot is braking or reducing speed, the energy that it's hosting is fed back to the grid. So that is used by a technology we call bidirectional rectifier. So if we are using energy from the grid, okay, so we pump it into the robot and make the robot move. When the robot is coming to a stop, we feed that energy back to the grid. And in this way, we will save up to 20% energy. So that is a first way really to make the operation of the robot efficient. On the next slide, there is a situation when you are using the robot and you are in operation, but as you all know, there are pauses in your production process. When the robot is waiting for a machinery or some other process equipment, or if you have a tacted production line, you're waiting for the next tact. So there are waiting time built into any process that we look at. And traditionally, you have kept the robot running with the motors energized. And when the motors are energized, you are fighting gravity. So really the robot is standing still, obviously, but it's fighting gravity and by that consuming a lot of energy. And for a large size robot, this is about 800 watts. So what you can do is to activate the brakes directly. You can do it within 3 seconds, 10 seconds, your choice. But if you activate it early, you are saving 800 watts during operational waiting times. So that is the second part we have. Now on the third part, when it comes to design of a robot system, and illustrated with this nice bear that is sleeping, it's what we call hibernate or wake on lawn. So imagine that you're going for lunch, or imagine that you're leaving the factory for the evening. It would be so traditional to leave all the systems powered up. But what if you want to save the energy that the robot system or any process equipment is consuming? Then we have what we call a remote switch. So a remote switch enables you to switch off all the robots from a PLC or some other equipment that you have centralized, and by that saving another 200 watts approximately. So it's consuming less than 5 watts in this status. So really 3. During operation, while waiting, and when you are downtime during nights, evenings, weekends, that really if you are active, you can save a lot of energy. So these are the things built into the system. When you program the robot. When you program the robot, that's really when you're running the robot, either you do a manual programming that is based on the experience of that specific person. Or you can use our software platform, Robot Studio, and that software platform, we can provide you with automatic path planning, meaning that we provide you with a starting point and an end point. And with a starting point and end point, the Robot Studio software will automatically generate the best path in between those positions. And it will, if you have simulated the environment in a CAD model, it avoids collisions, it gets the perfect uncollided path that it is. And in this way, you can reduce a programming time from approximately 45 minutes to 2 seconds. It's just a click away. You will reduce the cycle time, and best of all, you will reduce the energy consumption with, in this example, 36%, but it's an average we have. So depending on how complex path, you will save more. If it's a fairly simple path, maybe you will not save 36%, but it will give you the best ever path. So that was a fourth thing, how you program your robot. So we really are focusing on giving you the best opportunity to be sustainable.